The universe doesn't hand over its secrets easily. For every breakthrough, like measuring gravitational waves or mapping the human genome, other puzzles remain, untouched by even our most advanced tools. As 2025 unfolds, science still faces questions that resist clear answers, spanning the vastness of space to the inner workings of the mind. These are reminders that progress never eliminates mystery, it only sharpens it. Across the next 50 cases, you'll see brief scenes, recent research, and unanswered questions, each left open-ended. Some are brand new anomalies, others are ancient enigmas, and all remain unsolved. The first begins with a sound that refuses to be silenced. The hum. Imagine lying awake at night in supposed quiet, only to feel a deep vibration that never lets up. It doesn't sound like traffic or appliances, and checking outside reveals nothing unusual. Yet for some, this low-frequency drone persists day after day. This phenomenon is known as the hum, and in 2025, investigations and acoustic studies continue to document scattered reports across different regions. For those who perceive it, the experience can be overwhelming: restless nights, fatigue, and a constant sense that something is humming just out of reach. But microphones set up in affected homes typically record nothing beyond ordinary background static. One leading idea points to infrasound, those frequencies just below the threshold of normal hearing, suggesting that a minority of people may be unusually sensitive. Since the first wave of reports in the 1970s, scientists have suggested possibilities ranging from industrial machinery to natural sources, but no single explanation has matched the full global pattern. After decades of inquiry, the hum remains a paradox, sometimes felt more than heard, intensely personal yet impossible to trace. And it's not the only invisible presence science is still wrestling with. Dark matter. Galaxies move in ways that ordinary matter cannot explain. Stars on the edges spin too quickly, as if held together by a vast, invisible framework. This unseen mass has been named dark matter, yet despite decades of searches, no confirmed trace has ever been caught. Detectors buried underground wait for the tiniest signals, but their readouts remain blank. In 2025, one of the most precise efforts, the DAMIC-M prototype placed beneath the Alps, ruled out a proposed hidden sector scenario involving very light particles. Larger instruments are already being planned, each designed to probe deeper into the models that could account for this elusive substance. Still, the central puzzle has not budged. Dark matter appears to make up about 85% of all matter in the universe, and there is still no direct evidence of what it actually is. Theories at this point vary widely. Some focus on light hidden sector particles, others consider axions or even primordial compact objects. Each experiment narrows possibilities, but the essential question, what fills the cosmos beyond the visible, remains untouched. And unresolved questions are not limited to the stars. Some arise from the most personal terrain possible, our own awareness. Consciousness and the hard problem. Science can measure the brain's electrical patterns with extraordinary accuracy, yet one question remains untouched: why any of it should feel like something from the inside. This is the puzzle known as the hard problem of consciousness, the gap between neural activity and lived experience. In 2025, an adversarial collaboration led by the Allen Institute reported results from one of the largest tests of competing theories of consciousness. By monitoring brain activity during wakefulness and anesthesia, the project highlighted the importance of posterior cortical regions while also pointing to the thalamus as a key relay for conscious signaling. These findings offered valuable clues but did not eliminate the leading theories. Other studies continued to show that synchronized bursts of brain activity often match reports of self-awareness. Yet the same results stopped short of explaining why such patterns should give rise to subjective experience. We can map correlates of consciousness, networks that light up, rhythms that repeat. What we still can't do is explain why they carry the feeling of presence. That unresolved leap keeps the hard problem unsolved. And science meets a different kind of strangeness when it considers particles that appear to remain connected across the vast emptiness of space. Quantum entanglement. Quantum entanglement describes a link where two particles share behavior across distance, shift one, and the other seems to update at once. It defies ordinary ideas of cause and separation, and after decades of testing, the effect continues to hold. In 2025, experiments reported that entangled particles keep their correlations even under demanding conditions. Stretched across very large distances, surrounded by background noise, and exposed to environments that should disrupt fragile quantum states. Instead of fading away, the connection remained robust, exactly as quantum theory predicts. This matters for more than theory. The remarkable stability of entanglement points toward technologies like quantum communication, where information could be exchanged in ways that resist common methods of interception or hacking. The same principle may one day underpin secure networks that rest on physics rather than passwords. At the same time, quantum research continues to produce surprises, not resolutions. New results such as evidence of fractional excitons or unusual electron states in advanced materials show that each breakthrough deepens the strangeness rather than simplifying it. And the mysteries of physics mirror another frontier, where belief alone seems capable of shaping measurable change in the body. The placebo effect. A treatment with no active ingredient should leave the body unchanged. Yet in countless trials, inert pills and sham procedures produce genuine shifts in health. This is the placebo effect, a phenomenon that still unsettles medicine in 2025. One of the most striking examples comes from what are called open-label studies, where participants are told outright that they are receiving a placebo. Even then, many report meaningful improvements in pain, anxiety, or other symptoms. That defies the expectation that deception is required and shows how little we understand about how belief acts on biology. Brain imaging adds another layer. Scans often reveal measurable changes in neurotransmitters, opioid and dopamine systems shifting in the same direction they would under real medication. It's as if the brain recalibrates the body, adjusting its own chemistry simply in response to the expectation of relief. Researchers can track these cascades, but they still cannot explain why conviction alone is enough to set them in motion. For now, the placebo effect remains an unsettled frontier, reliable enough to appear again and again, unpredictable enough to defy simple theories. And science faces puzzles just as elusive in the natural world, where unusual lights still appear in the skies during storms. Ball lightnings. Witnesses have long described glowing spheres drifting through the air during thunderstorms, brief orbs of light that end suddenly in silence or in a sharp flash. The phenomenon is called ball lightning, one of the rarest and least understood events in atmospheric science. Modern cameras, from dashboard recorders to security feeds, have caught clearer glimpses in recent years, giving scientists better documentation than before, but still no resolution to the mystery. One striking report showed a small luminous orb drifting into a building through an open window, hovering for a moment, and leaving scorch marks on wood before vanishing. Stories like this raise questions about whether observers are seeing a purely physical discharge or some unusual optical effect. And while laboratory experiments hint at possible mechanisms, they rarely reproduce the same behavior in a stable, repeatable way. Competing theories remain on the table. Some propose self-contained plasma spheres, others suggest microwaves trapped in small pockets of air. But neither model explains details such as the variety of shapes and colors or the supposed ability of some spheres to pass through solid surfaces. Even with 21st century instruments, the lab still can't build the same thing reliably, reminding us that nature often outpaces our explanations. And that same sense of unanswered precision shows up not only in the sky, but also in the hidden guidance systems driving living creatures across the planet. Animal migration navigation. Every year, migrating animals embark on journeys that test the limits of endurance and precision. Birds cross oceans without pause, whales return to the same routes generation after generation, and delicate insects such as monarch butterflies navigate across entire continents to reach destinations they have never seen. The question of how they accomplish these feats remains unresolved, even as new GPS tracking programs in 2025 bring sharper details. Close study reveals flight paths and marine routes so straight they appear drawn against an invisible grid. Many species seem to rely on cues hidden from human senses, particularly the magnetic field of Earth. Evidence suggests that birds like European robins use cryptochrome proteins in their eyes as quantum sensors, possibly able to visualize magnetic lines, like seeing a map etched into space itself. The idea that navigation depends on a quantum process makes the challenge both stranger and more compelling, though exactly how such signals are processed remains unknown. Other clues point to whales shifting routes with gravitational variations, or creatures responding to deep, low-frequency sounds. A mosaic of partial answers has emerged, yet the overall mechanism is elusive. That lingering uncertainty keeps animal navigation among science's most persistent puzzles, and it naturally connects to another signal whose origin carries equally stubborn unknowns. The WOW signal. In 1977, a radio telescope in Ohio picked up something no one had seen before, a narrow, powerful signal that lasted 72 seconds. It was strong enough to stand out from background noise and sat right near the hydrogen line, a frequency often considered ideal for interstellar communication. When astronomer Jerry Amon spotted it on the printout, he circled the spike and scribbled a single word in the margin. Wow. The name stuck and the mystery began. From that moment onward, the signal has remained a one-time event. Decades of follow-up observations with more advanced instruments, far more sensitive than anything available in the 70s, have never caught another burst from the same patch of sky. Reanalysis of the 1977 data shows the transmission was too specific to dismiss as static, yet nothing similar has repeated. Proposed explanations have included passing comets, stray reflections from Earth, or classified transmissions, but none have held up under scrutiny. What lingers is a single clear anomaly, one transmission that fit the right profile for something deliberate yet never returned. Was it a fleeting natural event or a signal someone or something sent only once? Like other riddles we live with, it opens onto questions not just of space, but of our own perception of reality. Deja vu. It's that strange sensation where the present feels recycled, as if you've already lived this exact moment. Deja vu is quick, often gone within seconds, but it unsettles precisely because it feels so real. By 2025, brain imaging can capture what happens in real time when someone reports it. The scans suggest a brief mislabeling, where memory systems flicker just ahead of experience, making the brain tag a new moment as something remembered. Yet not every case follows the same pattern. Some describe the unmistakable familiarity of places they've never visited or conversations they feel they've already heard. Explanations point to the overlap between recognition and recall networks, as if two nearby circuits briefly misfire and trick awareness. Experiments show subtle pre-activation in memory regions during these episodes, but results remain descriptive rather than conclusive. What is clear is that deja vu is common. Psychological surveys reveal that many adults encounter it multiple times in their lives. Still, the mechanism behind it is incomplete, somewhere between a glitch of timing and a deeper quirk of perception. It's ordinary, widespread, and yet unsolved, an everyday reminder of how easily the mind can slip. And science faces similar one-off jolts of strangeness when telescopes capture sudden signals flashing across the sky. Fast radio bursts. Astronomers have spent the last 2 decades chasing a class of signals called fast radio bursts, millisecond flashes of energy that appear without warning from far-off galaxies. In that blink of time, a single burst can unleash as much power as the sun generates in years, a scale so vast it still strains comparison. By 2025, more than 1,000 bursts have been cataloged. Some erupt only once, never to be seen again. Others repeat from the same area of sky, giving scientists the chance to study them in greater depth. The pattern of those repeaters has strengthened the case for magnetars, ultra-dense neutron stars with magnetic fields billions of times stronger than Earth's. Their violent outbursts seem capable of producing many of the observed flashes, making them the leading candidate. But magnetars cannot yet explain the full story. A few bursts show repeating cycles longer than theory predicts, or structure within the pulses that standard models fail to capture. Those anomalies keep the mystery intact, suggesting that, for all our progress, part of this cosmic script is still missing. And unresolved puzzles aren't limited to the depths of space. Sometimes, they surface in unexpected places on Earth, hidden inside fragments of the past. The Antikythera mechanism. When divers first recovered a corroded lump of bronze from a shipwreck near the Greek island of Antikythera, it appeared to be nothing more than sea-worn debris. Decades later, X-rays revealed a hidden system of gears inside, turning that lump into one of archaeology's most startling finds, the Antikythera mechanism. What had seemed worthless was in fact a complex, hand-crafted device, centuries ahead of anything thought possible. By 2025, digital reconstructions allow us to see how the instrument once operated. Its interlocking cogs could follow lunar phases, predict eclipses, and mark the shifting paths of planets. For something built over 2,000 years ago, it functioned like an analog computer of the heavens, compressing cosmic rhythms into the turn of a crank. The greatest puzzle lies not only in what it could do, but in where it came from. The precision gearing rivals clockwork that would not appear again until 1,000 years later, yet no clear evidence of its workshop, tradition, or successors has been found. Radiocarbon dating and metallurgical studies provide knowledge of when and how it was made, but not who developed such expertise or why it vanished. The Antikythera mechanism endures as an engineering miracle lost to history, an isolated breakthrough that leaves behind more questions than answers. And some mysteries, unlike intricate bronze machinery, appear far less orderly, emerging in forms that are sudden, destructive, and curiously human. Spontaneous human combustion. On rare occasions, forensic investigators encounter remains so unusual they resist easy explanation. A body may be reduced almost entirely to ash, yet the surrounding furniture, flooring, or even clothing nearby shows little more than trace scorching. The scene looks less like an ordinary house fire and more like a localized cremation contained within a room. This combination of high heat with minimal external damage is what has long been called spontaneous human combustion. The most scientifically grounded explanation is known as the wick effect. In this model, body fat acts as fuel, absorbed into clothing that serves as a wick, creating a slow, smoldering fire that can consume tissue far more completely than an open flame. Tests in the 2020s confirmed that under certain conditions, the wick effect could account for some reported incidents, especially when a small spark such as a cigarette was present. Even so, not every case fits. Reviews continue to highlight examples where no clear ignition source was ever found, despite careful examination. That absence leaves a gap in understanding that modern forensics cannot close. Whether rare accidents, overlooked natural processes, or something less familiar, the phenomenon remains unsettled, an unresolved reminder that human biology can blur into the inexplicable. And from questions about destruction within the body, the next mystery shifts to something far subtler: the unseen ways behavior seems to ripple from one person to another. Yawning contagion. You notice someone yawn, and without intending to, your own jaw stretches open. The reaction feels automatic, as if wired into the body. This is yawning contagion, and in 2025 it remains one of the more curious habits shared across humans and even some animals. Research points to brain systems tied to empathy and social awareness, suggesting that when these networks activate, a simple yawn can ripple through a group. But the pattern is inconsistent. In certain studies, levels of empathy predict higher rates of contagion, while in others, the connection weakens or disappears. That variability complicates the idea that yawning is a straightforward marker of social bonding. Differences become clearer in neurodiverse groups. Children with autism, for example, sometimes show lower or delayed responses, and in other cases, no response at all. The results hint that while empathy networks play a role, they don't fully explain the effect. Timing adds another layer of uncertainty. For some, the reaction is almost instant. For others, minutes pass before another yawn emerges. So what is yawning contagion at its core? A form of social glue or nothing more than a reflex? We still don't have a single answer. And from these fleeting human jolts, science shifts to flashes on an entirely different scale. Gamma-ray bursts. Gamma-ray bursts are among the most extreme events the universe produces, brief flashes of radiation so intense they can outshine entire galaxies. In just a few seconds, one burst can release more energy than our sun will emit over its full lifetime. They usually erupt far beyond the Milky Way, distant enough to spare Earth but violent enough to reshape the galaxies where they ignite. Observations in recent years show that these bursts fall into different categories. Some are tied to the collapse of massive stars at the end of their lives, leaving behind black holes. Others arise when neutron stars collide, their dense matter smashing together with enough force to trigger jets of gamma-ray light. These mechanisms explain many of the short and long bursts scientists have cataloged and stand as the leading models. Even so, anomalies remain. Some bursts drag on far longer than expected for their category, while others blur the lines between short and long patterns entirely. That inconsistency shows that the framework is not complete. When nature packs the universe into a single heartbeat, we still can't fully read the message. And mysteries also wait closer to home, hiding not in the stars but in the rhythms of our own bodies. Sleep and dreams. Every night, sleep arrives as if it were a built-in command, shutting down awareness on schedule whether we are ready or not. Its importance is beyond doubt. Without it, the body breaks down, memory falters, and survival itself is threatened. Core functions are now clear. Sleep strengthens recall, stabilizes mood, and allows the brain to clear metabolic waste through the glymphatic system. But the deeper evolutionary reason why it is non-negotiable remains debated. It's as if we can see the nightly update taking place, but not the exact code that makes it indispensable. In 2025, laboratories continue to show that rapid eye movement, or REM, does far more than supply vivid dreams. During these phases, memory networks replay and reorganize information gathered during the day, while emotional centers reset stress responses. Brain scans reveal intricate cycles of activity, shifting between storage systems and areas linked to balance and regulation. On many levels, REM functions like a built-in therapy, quietly recalibrating thoughts and feelings while consciousness drifts away. Dreams themselves remain harder to place. Their surreal scenes often seem disconnected from biological housekeeping, yet they surface consistently alongside these restorative processes. Whether they are side effects of neural cleanup or signals with their own purpose, no answer has yet taken hold. Even when science maps the patterns, the ultimate question remains: why must every creature surrender to sleep when evolution prizes efficiency? That unresolved necessity points back to a larger theme. Whether looking inward or outward, there are mysteries that resist explanation. The Fermi paradox. If the universe contains billions of galaxies, each with their own stars and planets, it seems likely we should have met another civilization by now. This gap between high probability and complete silence is known as the Fermi paradox. By 2025, exoplanet surveys continue to reveal countless worlds where liquid water could exist, and many orbit in stable star systems. The sheer scale suggests life elsewhere is at least possible, if not probable. Still, no voice has answered back. Sensitive radio telescopes sweep broad regions of space, spacecraft carry instruments to check unusual signals, and observatories scan exoplanet atmospheres for hints of chemistry shaped by biology. Yet every attempt has returned inconclusive. The silence only deepens the puzzle. Hypotheses range wide. Some researchers argue that advanced civilizations rarely last long, undone by resource collapse or destructive technologies. Others suggest they may be active but hidden, communicating in ways we cannot detect, signals outside familiar physics, or methods that bypass electromagnetic waves altogether. Are we rare, hidden, or simply listening in the wrong way? For now, each new exoplanet expands the stage, while the lack of answers reminds us how fragile our assumptions can be, even about forces that shape our own planet. Magnetic field reversals. Every few 100,000 years, Earth's magnetic field doesn't just shift, it reverses. North becomes south, south becomes north, and the invisible shield that surrounds the planet changes alignment. Geological records examined in 2025 indicate that while another reversal is not expected within our lifetimes, the slow drift of today's poles makes clear this process happens on timescales of millennia. That distance in time eases immediate concern, but the process remains unpredictable. Magnetic minerals trapped in ancient lava flows reveal how past flips unfolded. Instead of a single abrupt switch, the field meandered over thousands of years. Strength weakened, poles wandered, and there were even failed attempts before the new alignment stabilized. These transitional periods invite questions about how well Earth's magnetic shield protected against cosmic and solar radiation when it was at its weakest. The evidence, however, sets boundaries. The fossil record shows no mass extinctions tied directly to these flips, suggesting that while the magnetic field waxes and wanes, life finds ways to endure. What scientists can say is that reversals are inevitable, periodic, and beyond precise forecasting. It's slow, mysterious, and measured on geological scales, pressing for researchers but distant from our daily lives. Not all mysteries, however, move so gradually. Some appear in sudden and extraordinary ways, through abilities hidden in the architecture of the human mind. Savant syndrome. Savant syndrome describes cases where highly specific abilities appear with striking clarity, often standing apart from the rest of a person's skills. Some individuals can recall entire pages of text after a single reading or calculate complex calendar dates instantly. Others display sudden and extraordinary talent in music or art that seems to arrive fully formed. In a few rare reports, these abilities emerge after brain injury or illness, what researchers call acquired savant syndrome, adding to the puzzle of how such isolated reservoirs of talent can exist. In 2025, advanced brain imaging continues to explore possible mechanisms. Scans often show unusual connectivity between regions that don't usually interact, almost as if hidden pathways open up and reroute information flow. Yet the findings are inconsistent. Two people with similar outward abilities may have entirely different activation patterns inside the brain. Theories range from neuroplastic rewiring after trauma to disinhibition within tightly controlled circuits that normally suppress detail in favor of broader processing. The sharp contrast between these isolated islands of genius and the everyday struggles many savants face deepens the mystery. Is there a hidden reserve of extraordinary skill in every brain, waiting for the right disruption to surface? Science cannot yet say. What remains clear is that these rare demonstrations remind us how much is still concealed beneath ordinary appearances, just as the natural world can conceal immense forces behind ordinary-looking waves. Rogue waves. For centuries, sailors reported colossal walls of water rising without warning, overwhelming ships before vanishing into ordinary seas. These accounts were often dismissed as legend, until satellites and deep ocean sensors began confirming their reality. By 2025, global monitoring shows that rogue waves can exceed tens of meters in height, sometimes even in calm conditions, proving those old reports were never exaggeration. Their danger lies in suddenness. One moment the water appears steady, rolling with predictable swells, then in seconds a massive crest surges upward, strikes with devastating force, and disappears before sensors record more than a glimpse. Entire vessels have been damaged or lost in such incidents, with surviving logs often serving as the only testimony to these fleeting catastrophes. Theories offer partial answers. Most point to constructive interference, where multiple smaller waves align perfectly to build one towering surge. Others look to nonlinear dynamics, where energy concentrates unpredictably in a patch of sea. Yet despite advanced oceanographic tools, no monitoring system can forecast rogue waves with confidence. For mariners, they remain the ocean's knockout punch, unexpected and deadly. And mysteries of unpredictability extend beyond the sea, into the very structure of reality itself. The fine-tuned universe. The constants of physics fall within razor-thin limits, and if they shifted even slightly, the universe would be unrecognizable. Stars might never ignite, atoms might fail to bond, and planets could not remain stable. By 2025, fresh measurements of values like the fine structure constant and the strength of gravity continue to show how fragile and improbable this balance appears. The cosmos seems tuned to conditions that allow complexity, and in our case, observers, to exist at all. Scientists agree on the precision of these margins, but not on why they are there. Some argue the answer could lie in a multiverse, an endless collection of universes where the constants vary, and we inhabit the rare one that permits life. Others suggest there might be undiscovered principles in physics that set the numbers exactly where they need to be. Still others regard it as coincidence, with no hidden design to uncover. The anthropic principle, which proposes that we notice these numbers only because we exist in such a universe, adds another layer of controversy. With no single explanation, the fine-tuned universe straddles the boundary between science and philosophy. It is a numeric riddle that keeps physicists and philosophers talking, and it also echoes a broader theme: the human tendency to sense patterns and order, even when confronted with absence. Phantom limb syndrome. A person can lose a hand or a leg yet still wake to the unmistakable sense that it's there. Fingers may itch, a foot may ache, or there may even be the impression of movement. This is phantom limb syndrome, where the brain's body map clings to absent parts instead of erasing them. For patients, the pain is real even when the limb is gone. Research in 2025 shows just how persistent these neural maps can be. Scans reveal that pathways tied to missing limbs remain active, firing as if the body were still whole. That activity helps explain why treatment focuses on retraining the brain itself rather than the site of amputation. Mirror therapy can trick the brain into seeing the absent limb respond, while newer virtual reality systems let patients control digital stand-ins. Relief is usually partial, but the response shows how powerfully the brain enforces its own design. The puzzle reaches even deeper. Some people born without a limb describe phantom sensations too. This suggests the blueprint for body awareness is present before experience, wired into the nervous system. That hidden design raises another question. What happens when vital maps in nature itself begin to vanish? Honeybee colony collapse. Bees pollinate a large fraction of the world's crops, yet their long-term survival remains uncertain. Over the past 2 decades, surveys have recorded substantial declines in many regions, and in 2025 the trend remains uneven. In some areas, managed colonies continue to experience significant annual losses, while wild populations show mixed outcomes depending on climate and land conditions. Where conservation measures are active, declines have slowed, but the global picture is far from stable. The pressures are layered. Pesticides interfere with bees' ability to forage and navigate, often leaving them unable to return to the hive. Climate shifts disrupt flowering schedules, creating mismatches between when plants bloom and when pollinators arrive. Industrial farming landscapes remove habitat diversity, forcing bees into food deserts with little shelter. On top of that comes the varroa mite, a damaging parasite whose range is expanding as temperatures warm. Each force is damaging on its own, but together they make colonies fragile from one season to the next. Even so, there are signs of resilience. Some wild groups show resistance to parasites, and protected areas have seen partial recoveries. The stakes, though, remain clear. If pollinators falter, many crops stand at risk. The lesson is that watching closely can change how we act, but in science, observation itself sometimes alters what exists in the first place. The observer effect. In physics, there is a strange rule at the quantum level. Particles do not behave the same when left alone as when measured. In the double-slit experiment, an electron or photon drifts through 2 openings like a wave, creating an interference pattern of light and dark stripes. But once a detector is placed to see which slit it passes through, that wave pattern vanishes and the particle leaves a single trace instead. The same particle can act like a wave or a solid object, depending only on whether its path is checked. By 2025, high-speed detectors have confirmed this repeatedly. The collapse of the wave function doesn't depend on a human eye but on physical interaction. Any measurement device triggers the change. This makes the effect reliable but not less puzzling. Why should the simple act of recording force possibilities to crystallize into one outcome? Different interpretations divide physicists. The Copenhagen view says probabilities collapse when a measurement locks a result. The many worlds view says all outcomes still happen, just in parallel branches we cannot reach. Neither perspective explains why measurement holds such a privileged role. Does nature need a witness to become definite? Science still argues about what observation truly means, and the uncertainty overlaps with one of the strangest puzzles of all: our shifting sense of time. Time perception. Time often refuses to match the strict rhythm that clocks display. Fear can drag a single minute into what feels like an endless stretch, while weeks of routine can blur together until they seem to vanish. This gap between measured time and lived time is one of the most persistent puzzles of the mind. Research in 2025 suggests that subjective distortions trace back to networks spanning the brainstem and cortex. These clusters appear to modulate how quickly the mind registers unfolding events, rather than simply keeping count of seconds. When stress surges, signals accelerate and moments feel extended. In repetitive settings, the same systems settle into slower cycles, compressing experience into a blur that slips past unnoticed. Laboratory experiments altering these pathways with stimulation tools produced vivid reports. Intervals that felt far longer than they were, or moments that seemed to skip ahead before attention could catch them. Such findings confirm that our sense of time can flex remarkably, detached from physics' uniform progression. But why awareness should carry its own variable clock is still unknown. For some, seconds stretch into minutes, for others, hours collapse into fragments. And the brain proves just as unpredictable when it begins blending entire senses together. Synesthesia. Sometimes perception itself strays from its usual boundaries. In synesthesia, the senses overlap in ways that defy neat categories. Sounds might appear as bursts of color, numbers can take on flavors, or letters may be tied to textures and shapes. Once thought rare, newer studies suggest it may be far more common than earlier surveys implied, hidden in everyday experience rather than limited to unusual cases. Brain imaging adds weight to those reports. Scans show cross-activation between regions that in most people remain separate, visual and auditory systems, for example, firing together when only one sense is stimulated. Genetic research hints at heritable factors, with synesthesia often clustering in families, though no single mutation has been identified as the cause. The biology points to real differences in how sensory networks wire themselves, but not to a clear explanation for why some people experience these vivid overlaps while others do not. That leaves an open question. Is synesthesia an evolutionary quirk, a hidden strength, or simply an alternate arrangement of circuitry? For some, the letter A might taste like blueberries or the number 7 might feel sharp and metallic. Such startlingly personal experiences highlight how perception can refuse to follow rules. And not all mysteries are contained within the mind. Some leave marks in the physical world, written on landscapes by forces no one could ignore. The Tunguska event. In 1908, a massive explosion tore through the Siberian wilderness near the Tunguska River, flattening trees across more than 2,000 square kilometers. The blast carried the force of a large thermonuclear device, yet when expeditions reached the site years later, there was no crater. Instead, they found forests radiating outward from a central point of devastation, but no circular scar to mark where an impactor had struck. Modern simulations now suggest the most likely culprit was a small asteroid or comet fragment that never reached the ground. Instead, it disintegrated in the atmosphere under immense pressure, producing an airburst that released destructive energy high above the surface. This model fits much of the evidence, explaining the radial devastation and the absence of an impact site. Still, irregular details persist. Eyewitnesses recalled glowing skies thousands of kilometers away, and some reports of unusual magnetic readings have never been fully reconciled. No verified fragments have ever been recovered, leaving scientists with models but no direct physical proof. The Tunguska event remains the largest modern impact mystery, an explosion capable of leveling a forest, yet leaving behind no smoking gun. It stands as a reminder that even overwhelming force can vanish without a clear trace, much as other kinds of imprint linger in ways we are still trying to understand. Muscle memory. Skills that once seemed to disappear often come back with surprising speed. An athlete who steps away for years may return and regain technique far more quickly than a beginner. This effect is known as muscle memory, though it is not confined to the muscles themselves. Research in 2025 shows that motor circuits in the brain and spinal cord remain partly primed, preserving outlines of learned movement even after long periods of inactivity. These patterns make it easier to reassemble skills later. Emerging evidence suggests the body itself may also hold traces. Studies point to epigenetic changes within muscle fibers, chemical markers that adjust how certain genes are expressed during repeated training. Unlike the short-term stress of exercise, these marks may linger, lying dormant until activity begins again. That could help explain why practiced movements return quickly once training resumes. Athletes in rehabilitation often report this acceleration firsthand. Finding coordination and strength reappear faster than simple fitness levels would predict. What remains unsettled is location. Does memory live in motor neurons inside the fibers of muscle or in the ongoing dialogue between the two? The answer continues to elude researchers, leaving this everyday mystery open at both the cellular and systemic level. And just as biology shows hidden traces, physics holds its own imprints, buried in the opening instant of the universe itself. Cosmic inflation. The early universe is thought to have expanded at a rate beyond imagination, stretching from subatomic scales to cosmic distances in less than a second. This rapid growth, known as cosmic inflation, now sits as the leading explanation in cosmology, though its inner workings remain unknown. Physicists can model what inflation would do, but the mechanism that set it in motion remains entirely speculative. The clearest evidence lies in the cosmic microwave background, the faint afterglow left over from the Big Bang. High-resolution surveys show tiny fluctuations scattered across that ancient light, exactly the kind of imprints inflation theory predicts. These fingerprints suggest that quantum ripples were blown outward and amplified into the seeds of galaxies. Yet while the observations continue to line up with the idea, no reliable smoking gun explains what force powered that sudden surge. Some researchers explore models with quantum fields driving expansion. Others wonder if the universe cycles through expansions and contractions. Inflation explains much of what we see, but the spark itself remains theoretical. And while the cosmos hides mysteries on scales larger than galaxies, there are puzzles much smaller, hidden in the physics of something as ordinary as water. The Mpemba effect. Sometimes hot water appears to freeze faster than cold. This counterintuitive result is known as the Mpemba effect, and in 2025 it remains one of the strangest experimental puzzles. Under controlled tests, some labs reproduce the effect clearly, while others fail to see anything unusual. Reproducibility itself is the core problem, keeping the debate alive. Several explanations have been put forward to account for it. One is evaporation. Hot water can lose volume before freezing, leaving less behind to solidify. Another involves convection currents that circulate heat differently, allowing some regions to cool more efficiently. Dissolved gases and impurities might also shift freezing points in subtle ways, changing outcomes from sample to sample. Each of these accounts works in certain trials, but none explains the effect under all conditions. That inconsistency is why the Mpemba effect remains unsettled. Something as routine as freezing water can still deliver contradictory results, with logic and expectation bending depending on circumstance. As researchers themselves note, even a bucket of ice can prove less straightforward than it seems. It's a reminder that nature retains surprises, even in the everyday, which only raises deeper questions about how living systems sense what we cannot. Animal sixth sense. Animals have long been linked to strange behavior before natural disasters strike. Earthquake stories often involve pets pacing at odd hours, livestock refusing to settle, or flocks of birds wheeling off in sudden flight. In 2025, GPS tracking of both domestic and wild animals has brought more structure to these accounts, showing measurable shifts in movement that sometimes precede seismic activity. In quake-prone regions, dogs and cats have been logged leaving sleeping areas moments before tremors, timing that is hard to ignore even if not universal. The most striking observations come from coordinated responses in the wild. Entire herds or flocks have shifted direction hours before seismic stations recorded the first waves, suggesting that animals may detect environmental cues hidden from human senses. Leading ideas point to sensitivity to very low-frequency vibrations or subtle physical changes in the ground. Others suggest chemical signals released by shifting rock or groundwater stress might reach animals in ways we cannot yet observe. The difficulty is consistency. Not every earthquake produces animal warnings, and not every bout of animal restlessness is followed by a quake. For now, the evidence shows correlation but not reliability, fascinating science, not a dependable alarm system. Mysteries like these highlight how much remains tied to unseen forces, whether picked up by animal instincts or probed by the deepest tools of physics. The God particle's mass. The particle first confirmed in 2012 as the source of mass in matter has not stopped raising questions. The Higgs boson, often called the God particle, remains central to physics because its measured mass directly affects theories of how stable the universe really is. Calculations show that its value could place our cosmos in a delicate condition, stable for now, but always on the edge of possible decay over unimaginable timescales. By 2025, particle accelerators have refined their ability to measure the Higgs mass with striking precision. Current results put it within a narrow window that draws special attention from theorists. In this range, the equations point to what is sometimes called vacuum metastability, a precarious balance in which the universe continues to function but might not be locked into permanent safety. The timespans involved stretch far beyond human horizons, yet the implications are already present in the numbers. The unresolved puzzle is why the Higgs boson carries the mass it does at all. There is no confirmed model that explains its exact value. A single particle has become the marker of whether our universe is ultimately secure or fragile, an unsettling thought mirrored in mysteries found much closer to the ground. Crop circles. Across wide fields, patterns sometimes appear pressed into the crops overnight. Circles, spirals, and geometric grids can stretch for hundreds of feet, the stalks bent cleanly at the base rather than snapped. Farmers often find them at sunrise with no clear markings, no tracks, no footprints, nothing obvious leading into the field. In 2025, drones remain the primary tools for documentation. Aerial mapping captures precise symmetry, showing how carefully many of these formations are laid out. Some designers have admitted to making them with simple tools like boards and ropes, and their markers, the irregular bends, the uneven spacing, often expose the method. Still, the speed and alignment of certain patterns continue to spark debate. Soil tests have occasionally reported unusual magnetic data at a few sites, but these findings appear inconsistently and have not been replicated in controlled study. Most researchers conclude that crop circles are almost entirely human-made, a blend of art, performance, and public spectacle. Yet the persistence of a handful of unexplained cases is enough to keep discussion open, sustained as much by public imagination as evidence. Mostly hoaxes, occasionally unexplained, human pattern-making meets mystery. And questions of precision versus anomaly play out not just in fields, but at the scale of the universe itself. The speed of gravity. For centuries, physicists wondered whether gravity acted instantly across space or if it traveled at a finite speed. The thought experiment was simple. If a distant star suddenly vanished, would its pull on planets disappear immediately, or would a ripple move outward the way light does? For much of history, the question was speculative, but the arrival of gravitational wave detectors finally brought evidence that could settle it. By 2025, observatories watching mergers of black holes and neutron stars had refined those measurements. Each new event showed gravitational waves racing across space at essentially the same speed as light, with no detectable gap. Within the precision of today's instruments, Einstein's prediction holds. Gravity does not leap instantly, but keeps pace with photons across billions of years of travel. Theorists continue to tighten margins, searching for any slight deviation that could hint at physics beyond relativity. But so far, wave after wave confirms the same outcome. Gravity and light travel together, locked at one speed, shaping the structure of the universe in tandem. So far, the universe behaves just as Einstein said. Not every puzzle, though, involves galaxies and cosmic forces. Some arrive in far smaller jolts, woven into daily habits. Phantom vibration syndrome. You feel a buzz in your pocket and instinctively reach for your phone, only to find nothing there. No message, no call, no alert. This sensation is so widespread it now has a name: phantom vibration syndrome. By 2025, surveys show it is very common among younger smartphone users, often convincing people to check their devices multiple times a day despite the absence of any signal. Neurologists suggest the brain adapts to near-constant digital input by lowering its thresholds for detection. Faint twitches in muscles, the tug of clothing, or random nerve firings can be misread as vibrations. The mind fills in the gap, anticipating contact before it actually happens. In this way, phantom vibration syndrome reflects both expectation and rewired sensory pathways. It is not just a psychological habit, but also a neurological one, where the body's perception reshapes itself to match technology's demands. The broader lesson is unmistakable. Tools that were once outside of us are now embedded so deeply in daily behavior that they create new sensory experiences. Technology gave us a new phantom limb, this time in our pockets. Other mysteries, however, leave traces not on our bodies, but in the vast reaches of nature. The bloop. In 1997, underwater microphones in the Pacific picked up one of the loudest deep ocean sounds ever recorded. The signal carried for thousands of kilometers, dwarfing the calls of even the largest whales. It was quickly nicknamed the bloop, and what drew attention was not only its volume but also its acoustic signature, which at first sounded vaguely biological. That resemblance sparked a wave of speculation about unknown creatures of unimaginable size. Subsequent analysis by NOAA and the US Navy, however, pointed in a different direction. The bloop most closely matched the profile of massive icebergs cracking and shifting, an icequake capable of producing enormous acoustic power. That explanation fits much of the evidence, but it does not fully resolve why such a sound has been so rarely heard in decades of continuous ocean monitoring. By 2025, the Global Hydrophone Network has tracked countless underwater events, yet nothing identical to the bloop has ever reappeared. Its source region happens to overlap with a set of coordinates mentioned in H.P. Lovecraft's fiction, an amusing coincidence but not evidence of anything more. For now, the bloop remains a single, unexplained anomaly, a reminder that even well-mapped oceans still hide surprises. And some of the most surprising patterns don't rumble through seawater at all, but emerge in the delicate rules driving life at the atomic scale. Quantum tunneling in biology. Quantum tunneling describes a particle slipping through a barrier it should not, by classical rules, have the energy to cross. It is one of the defining features of the quantum scale, matter behaving in ways that seem to bypass obstacles. What makes this more than theory is that life appears to use it routinely, not at the edge of physics labs, but inside the chemistry that sustains cells. In 2025, biochemists studying enzymes found clear signs of tunneling in action. Enzymes already accelerate chemical reactions far beyond standard expectations, but some reactions progress so quickly they cannot be explained by classical models alone. Instead, particles like protons or electrons bypass the normal energy hurdles, tunneling straight through and cutting down reaction times by orders of magnitude. In other words, biology is running on quantum shortcuts hidden under the hood of life. That tunneling is consistent across vital biochemical reactions suggests evolution did more than tolerate quantum effects, it relied on them. What remains unresolved is why natural selection came to use such delicate physics with such efficiency. The puzzle is not whether tunneling happens, but why life depends on it so deeply. And just as biology carries hidden vibrations of the quantum world, there are other hums and drones on our planet that remain far harder to trace. The Taos hum. In Taos, New Mexico, a fraction of residents report a low, humming vibration that seems to follow them everywhere. It isn't universal, most hear nothing. But for those who do, the droning presence is distinct and persistent. The phenomenon has been described since the early 1990s, yet no recording has ever captured it in a way that silences debate. Investigations using sensitive microphones and seismometers have found no consistent external signal, leaving science with perception but no matching source. Explanations range from industrial noise bleeding across long distances to the hum of electrical grids to tinnitus misinterpreted as an environmental sound. None fully account for the narrow frequency so many Taos residents describe, nor the fact that equipment regularly comes up blank while listeners insist it is real. The paradox is striking. Individuals hear the hum within precise ranges, but instruments do not. Only a minority of the town is affected, and they do not share obvious traits. For some, the sound is faint background. For others, it becomes an exhausting intrusion on daily life. The few who hear it call it unforgettable and maddening, and science still has no single answer. Mysteries like this remind us that the natural world holds patterns more enigmatic than expected, some of them as unsettling as sound, and others as beautiful as light. Bioluminescence evolution. Far below the ocean's surface, some creatures generate their own glow. Fish, squid, jellyfish, and even certain bacteria produce light and darkness where the sun never reaches, using chemical reactions carried out within their cells. The basic chemistry has been understood for years, but what remains puzzling is why the same trait is so widespread across such different organisms. By 2025, genetic studies make it clear that bioluminescence did not emerge from one shared ancestor. Instead, it evolved independently multiple times, appearing across unrelated lineages. Evolution found the same complex solution again and again. Given the intricate genetic coding required, the repetition seems striking, far too orderly to dismiss as random chance, yet too scattered to trace to a single origin. The functional reasons tell part of the story. Bioluminescence can draw mates, lure unsuspecting prey, or throw predators off balance, offering clear survival benefits. What lingers is the harder question. Why did such a specialized and elaborate chemical tool evolve separately in so many corners of life? Nature reinvented the same trick many times. Why is still a mystery? And not all of biology's puzzles are visible in glowing seas. Some remain locked in the pages of human history. The Vanish manuscript. The Vanish manuscript remains one of history's most persistent enigmas. Radiocarbon dating places its creation in the early 15th century, but who wrote it or why has never been resolved. Its pages are filled with looping script that matches no known alphabet, illustrations of plants that don't exist, and astronomical diagrams that fail to align with familiar skies. Generations of cryptographers and linguists have worked to decode it, and none have produced a translation accepted by experts. In 2025, artificial intelligence was trained on medieval language families, searching for hidden structure in the strange writing. Some models suggested fragments resembling Proto-Romance grammar, but these results fell short. The text shows patterns of repetition and syntax that behave like a real language, yet the accompanying drawings resist any direct match to medicine, botany, or star maps of the era. The manuscript continues to frustrate every attempt at a coherent explanation. Mainstream possibilities include an elaborate cipher, a forgotten language, or an elaborate hoax, yet after 6 centuries, none fit all the evidence. Today the book sits sealed behind glass in Yale's rare book library, its pages stubbornly silent. The puzzle of meaning lingers, pointing toward yet deeper riddles about what minds create and what minds perceive. Quantum consciousness. Some researchers argue that looking at classical brain signals alone misses something essential about awareness. A controversial idea known as quantum consciousness suggests that thought might depend on delicate quantum effects occurring inside the microtubules of neurons. These microscopic scaffolds usually handle cell structure and transport, but in this view, they could also support quantum states that scale upward into perception itself. In 2025, experimental studies reported faint hints of quantum coherence lasting within certain brain proteins. If such states are real, they would mean quantum conditions survive longer than expected in the warm, noisy environment of the brain. Supporters call this the missing bridge between physics and subjective experience. Critics, however, remain unconvinced. They argue that what's detected may be background interference rather than true coherence, and point out that biological tissue is one of the least likely places for fragile quantum states to persist. Most neuroscientists consider the hypothesis speculative at best. Still, it draws attention because it touches two unsolved riddles: how quantum mechanics operates and why consciousness exists. Is the mind purely classical or partly quantum? The jury is still out. And just as debates circle around hidden meanings in mind, there are also vast signs on Earth whose purpose has eluded explanation for centuries. The Nazca Lines. Across the desert plains of southern Peru, immense figures stretch for kilometers across the arid ground. These are the Nazca Lines, geometric shapes, spirals, and animal outlines etched into the soil and preserved for centuries by the dry climate. At ground level, their scale is nearly invisible, but from above, the full forms emerge, vast designs spanning the desert floor like deliberate strokes on an ancient canvas. In recent years, high-resolution aerial mapping has revealed additional figures hidden under sand drifts, expanding the already extensive catalog. Stylized birds, feline shapes, and long linear patterns join the well-known designs. Each was made by scraping away the darker surface to reveal lighter soil beneath, leaving clean lines that have endured for more than 1,000 years. Their purpose remains unsettled. Some researchers believe the animal motifs held ceremonial or religious meaning for the Nazca culture. Others point to geometric alignments that match solstice positions, hinting at a giant astronomical calendar. The difficulty is the extraordinary size and precision, entire figures hundreds of meters long traced without any way to view them in full. They remain giant messages etched in the earth, a mystery visible only from above, while other enigmas are written not in landscapes but within the workings of the human mind itself. Mirror neurons. When you watch someone raise a cup, tie a knot, or throw a ball, something unusual happens inside your own brain. The same neural circuits that would activate if you performed the action yourself begin to fire, as though your body is practicing in silence. These cells, called mirror neurons, create a mapping between observation and action, a system that turns watching into a kind of hidden rehearsal. Researchers study mirror neurons because they appear to provide a bridge between learning, imitation, and empathy. They seem to let us feel another person's movement or emotion by internally simulating it. This makes them a candidate mechanism for social learning and for the subtle ways humans share understanding. Yet the boundaries of what they truly explain are still unclear. Differences in how mirror systems respond have been observed in autism research, but scientists caution this is not a single cause, only one part of a larger puzzle about how the brain processes social cues. Some theorists even suggest these circuits played a role in shaping language and culture, turning shared action into shared meaning. One network that helps us feel what others do and might have helped human connection evolve, but its full role is still debated. And other forces far outside the brain show links on a scale just as invisible, drawing entire galaxies toward something we still cannot see. The Great Attractor. Our galaxy, along with thousands of others, is drifting at remarkable speeds toward a hidden concentration of mass astronomers called the Great Attractor. It is not a single object, but a gravitational region whose pull reshapes the motion of entire clusters. The Milky Way, Andromeda, and their neighbors all curve in that direction, sliding across space with no visible anchor to explain why. Refinements over the past decade show the Great Attractor is part of a still larger structure, the Laniakea supercluster. This colossal web stretches across hundreds of millions of light-years, containing tens of thousands of galaxies bound together by gravity. Yet the central source that drives so much of the flow remains obscured, its composition uncertain. From our vantage point on Earth, the densest part of this region sits squarely behind the zone of avoidance, the thick band of dust and stars that cuts across the disk of the Milky Way. That curtain hides direct images, leaving scientists to study the way galaxies move, not the mass itself. The mystery is not that we see it, but that we can only infer it. Our galaxy's path is bent by a force hidden from view. We're all being tugged by a gravity we can only measure in motion. And mysteries of unseen influence shape more than the cosmos. They also appear in the quiet moments when people insist the future finds ways of announcing itself too early. Premonitions and precognition. Some people describe sensing events before they occur, a sudden dread just before an accident, or a certainty moments before something unexpected happens. These experiences fall under premonitions and precognition, often dismissed as chance or selective memory, yet they persist in both personal stories and formal research. Decades of experiments on what researchers term presentiment suggest faint anomalies, tiny shifts in physiological or neural activity that occasionally appear seconds before random events. Statistical reviews in 2025 continue to show these small deviations, but replication remains the stumbling block. Effects tend to fade when experiments are repeated under stricter controls, leading critics to point to confirmation bias, flawed designs, or simple noise buried in the data. Supporters, however, argue that the persistence of even minor patterns over many trials makes the question worth keeping alive. For now, mainstream science remains unconvinced, demanding far greater rigor before any conclusions can be drawn. The debate highlights an unresolved divide. Are these glimpses of the future genuine signals, unconscious cues the brain picks up, or nothing more than probability playing tricks? Chance, bias, or something else? Science still pushes for better tests. And puzzles of hidden force and unexplained motion can be found not only in human experience, but lying silently on the surface of the Earth itself. The sailing stones. On the dry expanse of Racetrack Playa in Death Valley, stones seem to journey silently across the desert floor. Heavy rocks leave long carved trails behind them, stretching for dozens of meters across the cracked surface, as if moved by an unseen hand. For decades, this was a puzzle that nobody could watch unfold directly, only the mysterious tracks remained. Theories range from fierce desert winds to hidden magnetism, but without a clear witness, the phenomenon stayed unresolved. That changed with time-lapse cameras set directly on the playa. By 2025, monitoring studies confirmed the mechanism at work. On rare winter nights, thin sheets of ice form across shallow water. These sheets lock around the rocks, and as the sun warms the surface, the ice cracks and drifts under light winds. Hours later, the stones are slowly carried forward, etching fresh lines into the mud. It is a delicate process requiring a balance of water, cold, and breeze, which explains why no one had seen it in motion and why it occurs so rarely. Even so, differences linger. Heavy rocks sometimes leave oddly curved paths while lighter ones sit still, suggesting subtle factors we don't yet understand. The sailing stones are a mystery demystified mostly, and they hint at a wider theme. Nature often hides deeper rules beneath familiar surfaces. Quantum biology. Quantum biology explores how delicate quantum effects, usually confined to physics labs, appear inside living systems. One of the clearest examples lies in photosynthesis. Evidence now shows that excitonic energy transfer in plants, algae, and certain bacteria uses quantum coherence to move sunlight's energy with unusual speed and efficiency. Light absorbed by a leaf does not follow a single path, but briefly exists in multiple states at once before settling into the reaction center where sugar building begins. This coherence allows energy to explore all possible molecular routes simultaneously, then collapse into the quickest option. Instead of hopping step by step like a ball across a field, the energy wave flows and converges in the most efficient direction. The result is near-perfect transport that classical mechanisms cannot fully explain. Laboratory models confirm the effect, but the question remains: how are plants able to preserve such fragile quantum states when heat and noise normally destroy them almost instantly? Scientists call this the puzzle at the heart of quantum biology, nature protecting quantum information at room temperature on a vast scale every day. In short, plants are doing quantum engineering better than our laboratories. And while biology demonstrates hidden physics on Earth, some of the universe's faintest signals may hold mysteries just as perplexing, waiting in the skies for us to hear them again. The WOW signal too. Since the first WOW signal was detected in 1977, astronomers have returned repeatedly to that region of the sky, hoping for another trace of something so unusual. The original signal, a sharp 72-second burst, was narrow in frequency, intense enough to stand out above the cosmic background, and so distinct that it remains among the strongest candidates for an extraterrestrial transmission. It has never repeated, yet its singular clarity keeps observers on watch. Over the years, other isolated blips have surfaced. Some showed sharp spikes, brief bursts of energy that rose above the noise for an instant before vanishing again. These detections drew excitement because of their resemblance to features of the 1977 signal, but none matched it closely enough to be accepted as a true repeat. More sensitive instruments with broader sweeps have since been deployed, but after decades of listening, not one has captured a second wow. Skeptics point to coincidences, interference from Earth-based transmissions, or quirks of the detection equipment as the likeliest explanations. Supporters hold to the possibility that the original event really was a fleeting message that never returned. For now, the puzzle remains unresolved, and the world still waits for a clear hello from the stars. Patterns that hint at hidden order are not limited to deep space. They also appear here on Earth, in the movements of living creatures that act together as if driven by a single mind. Collective animal behaviors. A swarm of locusts crossing farmland or a school of fish shifting as one shape can appear less like thousands of individuals and more like a single organism in motion. This phenomenon, known as collective animal behavior, shows each creature obeying only local rules, yet the group produces seamless coordination. In 2025, GPS microtagging revealed just how quickly it happens. Animals adjust to their nearest neighbors in near instantaneous steps, sometimes faster than typical human reaction times. What makes this remarkable is the absence of a leader. Birds in a flock respond only to those beside them, yet wide formations ripple in waves. Fish redirect together in perfect arcs, and insects tighten or expand their groups as if choreographed. From these fragments emerges order on a larger scale, patterns that can resemble a single brain commanding many bodies. Computer models recreate much of this behavior using simple interaction rules, but they miss a crucial detail. The real pace of information transfer runs beyond what those rules predict. Energy and timing sweep through groups in ways simulations have not yet captured, leaving biology's explanation incomplete. We understand the structures, but not how such speed takes hold. And that gap points toward a broader problem. Sometimes hidden orders suggest deeper realities that even our best theories cannot yet describe. The multiverse theory. In 2025, theoretical physics continues to engage with one of its boldest ideas, the possibility that our universe is only one among many. This multiverse theory arises naturally in several mathematical models, particularly in string theory and inflationary cosmology. If space expanded faster than light in the very first instant after the Big Bang, then some versions of inflation suggest it could have generated countless separate regions, each isolated from the others and possibly governed by different physical constants. The challenge is that any testing runs up against observational limits. Telescopes can only reveal one horizon, the distance light has traveled since the birth of our universe. If other realms lie beyond that, no signal can cross the boundary, locking their presence behind unyielding limits of measurement. Proposals that anomalies in the cosmic microwave background might reveal collisions with other universes remain intriguing, but none has risen beyond debate. The evidence so far reflects patterns in mathematics, not results in data. That leaves the multiverse suspended between formal theory and imagination. A grand idea with zero direct evidence, beautiful math, brave speculation, and unresolved testability. And questions of this scale inevitably raise something larger still. The ultimate question. Every long list of unsolved puzzles eventually points back to a bigger one. Why does anything exist at all? This is sometimes called the ultimate question, and it stands apart from the others because it doesn't ask how forces or particles behave. It asks why there is a stage for them in the first place. The laws of physics can map how galaxies form, how neurons fire, or how space stretches, but none of these frameworks explain why there is something rather than nothing. Every experiment starts after the assumption of existence is already in place. In 2025, conversations between physicists and philosophers continue to edge into this territory. Some argue that quantum fluctuations in an empty vacuum could spawn entire universes, but this leads to another deeper why about the origin of those quantum conditions themselves. Others focus on the multiverse, suggesting that countless trials would make a universe like ours inevitable, but that only shifts the riddle to a larger, unexplained whole. Science can probe mechanisms within existence, but the question of why existence itself is here lies beyond empirical reach. So it remains unanswered, the largest puzzle of all. Which mystery in this entire list surprised you most? Share your thoughts below. From unseen structures in the cosmos to phantom sensations in our own bodies, the puzzles of 2025 remind us that science has clear borders we have not yet crossed. Each unanswered question is not failure, but evidence that the search for clarity is still alive. What we think is settled often shifts with new evidence, while the improbable remains part of the landscape. These 50 examples show that knowledge is not a finished chart, but an active frontier, always changing. Every explanation uncovers new uncertainties, extending the horizon and pressing us toward sharper tools, deeper studies, and harder questions ahead.